The focus of this video is going to be compound events. And when I talk about compound events, I'm talking about events that are formed by combining two or more events. And a lot of times when we're dealing with compound events, we're talking about the probability of one event or another. And so you'll see that this idea of P of A or B is going to be a central focus in this particular video. Now, the best part about these compound events and the probability of one event or another is that a lot of times we actually have the ability to reason through these problems. So as we look at example 1, you'll see exactly what I'm talking about. So it says the following contingency table represents a sample of customers at a restaurant. So you can see that we have some men and women at the restaurant, we have regular pop drinkers, we also have some diet pop drinkers, and we have a nice breakdown of who's drinking exactly what. So let's look at the first question. The first question says, what is the probability that a randomly selected adult is male and chooses diet pop? Okay, so based upon that question, I would say, well, let's identify all of the males who are choosing diet pop. And you could see that that would be these 22 males right here. And then we would want to take that number and divide it by the total number of people that we have at this particular restaurant. And so let's take 22 and divide it by the sum of 12 and 22 and 16 and 28. And so we can go into the calculator over here and do this. And actually, let me just do this first. I'm going to say 12 plus 22 plus 16 plus 28. And we could see that our denominator, the total number of people at this restaurant, is equal to, or at least in this survey, is equal to 78. So the answer to part A is going to be 22 divided by 78, because there were 22 people that satisfied the characteristics of being male and choosing diet pop out of the 78 people total. And if we want to compute the decimal or the percentage, we can actually divide this out. 22 divided by 78 is equal to approximately 28%. So 0.28. Okay, example B. What is the probability that a randomly selected individual is male? So again, applying that fundamental probability principle, let's identify the total number of males. And after I get the total number of males, I'm going to divide by the total number of people at the restaurant. And again, we know the total number of people at this restaurant is 78. So to get the total number of men, we would just go to the men column and say, okay, well, we have 12 men in this category and 22 in this category. So that would be a grand total of 12 plus 22, or 34 men. So this is going to be equal to 34 divided by 78. And once again, if we compute this in the calculator, 34 divided by 78 is going to give me right around 43.5%, but let's round up to about 44%. Okay, let's go on to example C, and they're going to get a little bit more difficult, but I'll show you how we're going to deal with them. So in example C, it says, what is the probability that a randomly selected individual chooses regular pop? Okay, well, here, what we want to do is take the total number of regular pop drinkers, and then we are going to divide that number by the total number of people. And so again, that denominator is going to be 78, but to get our numerator, let's go to our regular pop drinkers, and we could see that we have 12 male regular pop drinkers, and then we have 16 women regular pop drinkers, for a grand total, if you add across here, 28 regular pop drinkers. And if we do 28 divided by 78, we end up getting about 36%. So approximately 36%. Okay, now the most difficult part of this question is this very last part. So in this last part it says, what is the probability that a randomly selected individual is male or chooses regular pop? And so I want you to look at this question by reasoning. And let's look at the table again. So if we just go back to the table, I suggest looking at the individual cells and say, in each cell, is this a cell of males or regular pop drinkers? So for instance, this very first cell up here, is this males or regular pop drinkers? Yes. Now it happens to be males who are regular pop drinkers, but the answer to the question of are these males or regular pop drinkers in terms of a yes, no, would be yes. And so we would circle that 12 right there. How about this 22? Are these 22 males or regular pop drinkers? Yes, they're not regular pop drinkers, but they are males, and so I would circle that one. Are these 16 people right here males or regular pop drinkers? Well, they're not males, but they are regular pop drinkers, and so again, I'm going to be including that. And then in this cell, are these males or regular pop drinkers? Well, they're not males, and they're also not regular pop drinkers, so I would not be circling this. So in other words, the setup for answering this last question, the probability that a randomly selected individual is male or chooses regular pop, will be the grand total of males or regular pop drinkers, which is going to be 12 plus 16 plus 22, and then we are going to divide that number by our total, and again our total is 78. And so if we add 12 to 16 to 22, we end up getting 50. And so 50 of the people at this restaurant are males or regular pop drinkers. So let's do this, 50 divided by 78, and we see that we get a number of approximately 64%. Okay, now let's take a look at this problem in an alternative way where we visualize it in what's called a Venn diagram. So I'm going to sketch a Venn diagram illustrating exactly what we have in the table, and you can see I've recopied the table right here. And so I have my first circle representing the males at this restaurant. And as we're seeing, there's a little bit of overlap between the males and the regular pop drinkers. Okay, so the second circle is my regular pop drinkers. Now, if we look at the table, we can see that we have 12 men who are regular pop drinkers, and so I'm going to indicate that with a number right here. So what I have in what's called the intersection of these two events, or these two circles, is 12 people. Okay, so how many people do we have in this portion of the males circle? Well, we had 12 regular pop drinkers, but then we had 22 other males who were diet pop drinkers. And so this section in here of the males circle, where I'm cutting it off and I'm not including what's happening in here, is 22 more people. So we have a grand total of 22 plus 12, we have 34 males. We could do the same thing with regular pop drinkers. We have 12 male regular pop drinkers, but then outside of this section, but still within the regular pop drinker circle, we have another 16. And in statistics, when we talk about the probability of one event or another, I want you to know that the word or, when we use it in this class, is referring to the union of two events. And so the union of the event of being male and being a regular pop drinker would be everything that we have inside all of these circles. So the union is going to be 22 plus 12 plus 16, because that is everything inside the entirety of the Venn diagram. And that's another reason why we're taking 22 plus 12 plus 16, and then we ended up dividing by the grand total number of people. Okay, but if you look at this Venn diagram, we can also derive a formula for computing the probability of being male or choosing regular pop. And then we can generalize that to the probability of one event or another, regardless of what those two events are. So look at this. If you look at this Venn diagram again, we can figure out the probability of being male by just looking at this first circle. And you'd say, oh, well, the probability of being male is going to be 22 plus 12. That would be 34 out of 78. And so let me write this down. That would be 34 out of 78. And then I could say, let's add that to the probability of being a regular pop drinker. And so now I could add everything in this circle. And you could say, okay, well, the probability of being a regular pop drinker would be 12 plus 16. That would be 28 out of 78. But then you can see that if I added all of the males, and then I also added all of the regular pop drinkers like I just did, that I am actually covering this intersection area twice. And so instead of adding all of these numbers up and then separately adding all of these numbers up, And continuing with the problem, we need to say, hey, we counted this twice, so let's subtract one of those off. And so I would subtract that intersection of being male and a regular pop drinker. And so in general, the formula for the probability of one event or another is going to be equal to the probability of the first event plus the probability of the second event, and then it's going to be minus the probability of the intersection. And the intersection is often written as the probability of A and B, saying that both of those events are occurring at the exact same time. So my recommendation in a problem like this, when they're giving you a table, I think that it's simple just to kind of go through the cells like I did when I first answered this question and see, do these 12 people fit being male or regular pop drinker? Do these 22 people, do these 16 people, do these 28 people, etc.? And if they do, you can include them as part of your numerator. But you do have this option of saying, you know what, hey, this is a OR question. This is a compound event question involving that OR word in statistics, and I know that that means I should use the probability of A or B formula. And so if you're more of a formula person and you're more structured that way, absolutely feel free to do the probability of A plus the probability of B minus the probability of the intersection. Okay, now let's see if we can apply that in another example. So in this next example, we're looking at a deck of cards. And again, let's do our best to reason through this as we're looking at this. So the first part says, let's find the probability of drawing an ace. And so you're looking at the deck of cards, and we recall from an earlier video that we have 52 cards here in our deck. And so the total number of outcomes in our sample space is 52. That is our denominator. And let's figure out the number of ways that this particular event can happen. How many ways can we draw an ace? Well, we have an ace here, we have an ace here, we have 4 aces total. So 4 out of 52 is the probability of drawing an ace. And if we compute that probability, we see we get a number approximately 8%. Okay, let's continue. Let's go to this second part where it says find the probability of drawing an ace or a red card. Now, as soon as you see that word or in these problems, you're thinking to yourself, we do have a formula for approaching this. But I also want you to know that when you have a table or you have something that's completely listed out like we see here, you can approach this from a reasoning perspective. So let me look at it from a reasoning perspective with you right now, and then we'll also look at it from the formula perspective. So from a reasoning perspective, the word or means union. I want the union of cards that are aces or red cards. In other words, I want the grand total of all cards that can be classified as either aces or red cards. And then we'll take that grand total and we will divide by 52 because there's 52 cards in the deck. Okay, so let's go back and identify all of the cards that are aces or red cards. And when we look back at this image, we can see that here's all of our red cards. We have 26 red cards. Out of the 52 cards in the deck, 26 of them are red. Now, if we looked at all of these red cards that you see right there, and then you also wanted to include in union with those anything else that was also an ace, then you would additionally consider these couple of aces right here. So we have 26 red cards, and then we have 2 additional cards that are also aces. And remember, we're looking for all cards that are either aces or red cards. We're looking for the union, and the union in terms of, I guess, visually looking at what that union is, I could even draw it like this. I could circle all of the aces and then all of the red cards like this. And you can see that that grand total of aces and red cards is equal to 26 plus the additional 2. So our answer to this question is going to be 28 out of 52. Okay, so from a reasoning perspective, we are getting an answer of 28 divided by 52, and that is approximately 54%. Now, if you want to look at from the formula perspective, when you see that word or in there, remember that the probability of one thing or another is equal to the probability of the first event plus the probability of the second event minus the probability of the intersection of those events. And so in this context, event A would be an ace, and so we can say the probability of an ace or a red card would be equal to, so event B is a red card, would be equal to the probability of an ace plus the probability of a red card minus the probability of the intersection. The intersection is the probability of getting a red ace. And so this is taking the grand total of all of the aces, dividing by 52, so that would be 4 divided by 52. Let's look at the grand total of all red cards, 26 divided by 52. Half of the cards are red. And then you've double counted a little bit, right? You've counted 4 aces here, but then in looking at all of your red cards, the 26 cards, you've actually double counted a couple of the aces that were already counted here. So we subtract off red aces. We have 2 red aces out of our 52 cards. And you can see once again that if you just add these fractions, you get 4 out of 52 plus 26 out of 52, that's 30, minus 2 out of 52. You end up with a numerator of 28, and again, this is out of 52. 28 out of 52, 54%. So take your pick in some of these questions. Try to reason through it. I actually think that's the easier way in some of these, or you can use the formula. Okay, just a couple more. Let's find the probability of drawing a red ace. Well, if we go back to what we just did in this last example, we have 2 red aces in the deck of 52 cards, and so that probability is just going to be 2 out of 52. So if we do 2 divided by 52, we end up getting an answer of about 4%. So that's just the fundamental probability principle. And then this last one, we see that word or once again. And it says find the probability of drawing an 8 or a king. And so again, we can go back to the cards and we can identify the total number of cards that are 8s or kings. Now we know that there are 4 8s. We have 4 8s and we also have 4 kings. Are there any 8s that are also kings? Are there any kings that are 8s? No, that can't happen at all. And so in this case, when we go back and we look at that deck of cards and we identify that there's 4 8s and then there's separately 4 kings, we see that the likelihood of drawing an 8 or a king would be 4 plus 4 or 8 out of 52. And 8 out of 52 is equal to, about 15%. Okay? Now, if you wanted to, you could apply the formula again. You could say, let's look at the probability of an 8 or a king by saying, what's the probability of an 8 plus the probability of a king, and then subtract the probability of getting a card that is an 8 and a king. The probability of an 8, 4 out of 52. The probability of a king, 4 out of 52. What is the probability that you select a card that is both an 8 and a king? Well, that can't happen. So that probability is actually 0. And so you can see that even from this formula approach, we end up getting the exact same answer of 8 out of 52. Now, this type of situation where the intersection of these two events is equal to, or there is no intersection of the two events, the probability of 2 events occurring at the same time is equal to 0, we give that a special name. We actually say that these events right here, being an 8 and a king in the deck, at the same time, we say that they are mutually exclusive. You cannot have this event at the exact same time as you have this event. And in that case, we call those 2 events mutually exclusive. I'll go into some more detail about the definition of mutually exclusive in the very next video, so go ahead and check that one out now. Thanks.